Many parents and children wondered why algebra is taught in school, as they find it of no use. Why do people have such a negative attitude to algebra? What can we do to improve the situation? In this video, I shall try to answer these questions. Children first come across algebra as generalized arithmetic, that is, when they study arithmetical patterns and relationships. For instance, when we multiply different numbers by 10, say 10 into 1 equals 10, 10 into 2 equals 20, 10 into 3 equals 30 and so on. We can observe a pattern in the product. This pattern helps us form a general rule about the process of multiplication by 10, namely, to obtain the multiple of any natural number by 10, shift every digit of the number leftwards by one place and put a 0 in the ones place. To generalize from specific instances and to specialize from general relationships is an essential part of mathematical thinking. This mental ability is not restricted to mathematics. We need it often in our day-to-day life. We expect the sun to rise in the east and set in the west every day. One thing, we need to think about the difference in the use of in general, in ordinary language and in mathematics. When we use this term in English, we mean most of the time, not necessarily in every case. For example, in general, the monsoons arrive in Kerala by the end of May is an accepted statement, even though it is not true in certain years. But when we use in general in mathematics, we mean that the statement that it is applied to is true for all the cases for which the conditions are satisfied. Thus, in general, if the rightmost digit in an integer is 5, then the integer is a multiple of 5 is acceptable mathematically because it is true for all integers whose rightmost digit is 5. But the statement in general prime numbers are odd is not mathematically acceptable even though it is true for all primes except the prime number 2. The skills children learn while studying algebra. As children get more and more opportunities to generalize in real life and in mathematics, they gradually develop their ability to deal with abstractions. They learn to think of using the language of algebra. It helps them to be more logical, clear and precise in their way of thinking and in expressing rules and relationships. The essence of algebra is abstraction. Abstraction is a generalization of multiple ideas into a single concept. It is almost like looking at a city from the air. From the air, many characteristics of the city become easily observable. We are also able to see connections of various parts of the city with one another. These connections may not be easily visible to a person on the street. Abstract ideas in arithmetic. In math, a statement like 2 plus 3 equals 5 is a generalization of an infinite number of real life stories involving objects, incidents, ideas and actions. The individual objects, events, etc. have been removed, leaving only the essence of the meaning of a situation. We focus on the relation between 2 and 3 and not worry about if the story is about apples, oranges, sheep or something else. Arithmetic itself contains many abstract ideas. Algebra takes the abstraction of arithmetic to another higher level. To appreciate a major reason for studying algebra, look at this problem. A number and half of it add up to 63. What is the number? How do we solve this problem? Can we do it by trial and error? That is, by assuming a number to start with and proceeding to solve the problem. Let us assume the number to be 100. According to the information in the problem, 100 and half of 100 should add up to 63, but it doesn't. Let us try other numbers. None of these numbers are giving us the result. It appears cumbersome. Now, why don't we just take a general number, call it x and move from there? We know that the sum of x and half of x is 63. That is, x plus half x equals 63. That is, 3 by 2x equals 63. We get x equals 42. The number is 42. How easily we got the number merely by using a general number x? This is an instance of the use of algebra for solving seemingly complicated problems easily. I think you would agree that children need to study algebra. Continuation of patterns. While transition from arithmetic to algebra, we can see that patterns connecting numbers remains same. It would help children to learn easily if attention of children is drawn to this fact. 2 plus 3 equals 5. 2 apples plus 3 apples equals 5 apples. 2 hundreds plus 3 hundreds equals 5 hundreds. 2x plus 3x equals 5x. 2x squared plus 3x squared equals 5x squared. Children should learn it through a process that they enjoy and which keep them interested. We must look at some innovative and effective ways of learning and teaching. Teaching algebra that may make children algebra friendly and algebra child friendly. I will be back with another interesting video on this topic. Thanks for watching. Please like, subscribe and share this video. Bye.